Hi, everyone. Today we're talking vulnerabilities in cloud services and the CSP's responsibilities for dealing with them across the three basic service models: IaaS, PaaS, PaaS, and SaaS, SaaS. We'll use hospital cloud-based information technology systems, or HITS, as an example. When those apps live in the cloud, your patient's electronic protected health information, or ePHI, lives there too. Your job as a cybersecurity analyst is to keep that data safe without slowing care. This video's objectives are to enable you to spot cloud threats and vulnerabilities and understand how they differ from on-prem, and understand who protects what in SaaS, PaaS, and IaaS, so you can hold the right party accountable. On-prem, your hospital owns the stack: building, racks, hypervisors, operating systems, apps, and backups. In the cloud, you rent pieces of that stack. You gain speed and scale, but you also rely on the provider for parts of security. The HIPAA still applies in both worlds, but cloud providers become business associates, so you need a business associate agreement, or BAA, and due diligence on their safeguards. When you move to the cloud, two cloud-specific shifts in security management occur: multi-tenancy and internet-exposed control planes. Your resources sit beside other customers, and most access is via public APIs. Missteps in identity, keys, or configuration can expose data fast. Industry threat work shows misconfiguration, insecure APIs, and weak identity controls among top cloud risks. And shared responsibility. Who patches what depends on the service model: SaaS, PaaS, or IaaS. You always own your data, identities, configurations, and how ePHI is used. Here are the problems you'll see most often in hospital or other cloud implementations: identity and access mistakes, overprivileged roles, weak MFA, static keys, and stale service accounts. Attackers love stolen tokens because cloud is all API. Think least privilege plus strong MFA everywhere. Misconfigurations: open storage buckets, permissive security groups, public snapshots, and default settings left in place. Cloud makes it easy to spin up, and just as easy to ship something unsafe. Insecure or unmanaged APIs. Shadow integrations, missing authentication, or weak input validation expose ePHI at scale. Supply chain and third-party reliance. You depend on your provider's uptime, its sub-processors, and your own SaaS add-ons. Outages or vendor breaches can ripple into patient care. Use frameworks and BAAs to manage that risk. Ransomware and availability hits. Cloud doesn't remove ransomware risk, it changes it. Attackers target identity, backups, and SaaS data. Sector reports continue to rank ransomware and availability threats near the top. These vulnerabilities are similar to those on-prem, but there are significant differences, including speed and blast radius. A single bad policy can expose an entire region in minutes. Control plane attacks. If an admin account is taken over, everything behind it is at risk. Visibility. Logs exist, but only if you turn them on, root them, and actually review them. Physical controls. In cloud, the provider handles the building and hardware. You verify through contracts, attestations, and audits, not by walking the data center floor. Regulations often cover business use of data, requiring organizations to ensure their governance oversight includes managing cloud vulnerabilities. For our healthcare example, the HIPAA is an important regulation to consider. The HIPAA's security rule requires administrative, physical, and technical safeguards to keep ePHI confidential, intact, and available. That means doing a risk analysis, controlling access, auditing activity, and responding to incidents, no matter where the servers live. In the cloud, the provider is a business associate and must protect ePHI too, via contract and practice. For practical how-to, NIST P866 revision, 2 maps HIPAA safeguards to controls and to NIST 853, which many cloud shops already use. It's a great bridge from compliance language to security engineering. Understanding who is responsible for managing the vulnerabilities changes as we move across the cloud service models. For SaaS, the cloud service provider secures the app, platform, OS, and physical environment. Delivers features like encryption at rest, logging, backups, and tenant isolation. Offers compliance artifacts and signs a BAA. The hospital owns data governance and access with MFA, RBAC, and least privilege. It is also responsible for the configuration of security settings, DLP and sharing policies, incident response, and integration logging. You must review the vendor's controls and make sure the BAA covers sub-processors. For PaaS, the cloud service provider secures runtime and OS for managed databases, functions, containers, etc., plus the physical layer. The hospital secures application code, queries, secrets and keys, network policies, and data classification. Enables encryption, often customer-managed keys, sets firewall rules, and collects logs. For IaaS, the cloud service provider secures buildings, hardware, and hypervisors. The hospital secures guest OS patching, IAM, network segmentation, storage policies, images and snapshots, vulnerability management, and backup and restore tests. You still need a BAA and proof of controls. When implementing and managing sensitive data in the cloud, we need to pay attention to a critical set of activities designed to protect it. Identity first, enforce MFA for admins and clinicians, short-lived credentials, and least privilege. Encrypt by design. In transit, for example, TLS 1.3. And at rest, prefer customer-managed keys for sensitive stores. Log everything that matters, API calls, data access, and admin actions. Ship to a SIM you control. Segment and monitor. Private networking, deny by default, micro-segmentation for critical workloads. Backups that actually restore. Immutable copies, tested drills, and clear recovery point objectives, and recovery time objectives for clinical systems. Vendor governance. Signed BAA, review of data subprocessors, incident SLAs, and mapped cybersecurity framework controls. Before we conclude this lesson, I'd like to provide you with resources for common industries that can help organizations get started on building a cloud vulnerability management program. For finance, U.S. financial institutions, the FFIEC Joint Statement, Risk Management for Cloud Computing. Practical expectations for due diligence, contracts, shared responsibility, and ongoing oversight is a good resource. For healthcare, the HHS OCR Cloud Computing and HIPAA, clear Q&As on BAAs, ePHI handling, encryption, and responsibilities. When using cloud services, helps understand how to get service providers on board for ePHI protection. For publicly traded companies, the SEC Small Entity Compliance Guide, Cybersecurity Risk Management, Strategy, Governance, and Incident Disclosure. What board/management must implement and disclose helps management understand what is needed. For any organization subject to the GDPR, the EDPB guidelines. 07/2020 on the concepts of controller and processor. Crucial for cloud vendor roles, DPAs, and allocating legal responsibility help organization extend privacy protections to the cloud. Use of standards of best practice, such as the ISO 27000 series COBIT and the NIST cybersecurity framework, are applicable across all industries. Cloud doesn't erase your regulatory and ethical duties to protect any sensitive information. It changes how you meet them. Know your shared responsibility line, configure safely, and verify your provider's claims. Do that well, and the cloud can raise your security bar while keeping care moving. That's it for this lecture. If you have questions, be sure to ask in course questions. Helpful links to relevant resources are included in the video transcript attached to the lecture post.